Solve each equation by graphing. Where necessary, give solutions to the nearest tenth. Explain why. Okay, so this is going to tell us that this might have been a graphing calculator kind of question to solve. We're going to draw a sketch of it without our graphing calculator, and then we're going to find out if we need to have a graphing calculator to solve this. So for A, again, I'll color code this. I'm going to do one graph in blue and one graph in green. And in order to do the green graph, I need to be able to graph the inside, which I'll do in orange. So the blue graph is the easiest. Y equals 3 is a horizontal line going through the y value of 3. The orange graph is not hard because it's a parabola in vertex form. Can you see that your vertex is going to be at 0, -3? And having an A value of 3 means you go over 1, up, over 1, up 3, over 1, up 3, then over 1, up 9, over 1, up 9. It's a good review of graphing parabolas as we get ready for our exam. So our green graph, which is the absolute value, our green graph will take our orange graph, and wherever it was positive, it will stay positive. So that part, absolute value, wouldn't change. But wherever your orange graph was negative, that will get flipped up. And so there's our absolute value graph. And I can see from here, 0, 3 is a solution. But unfortunately, this point in purple and this point in purple are not easy to see from the graph because they're somewhere between 1 and 2 or -1 and -2. So this would be a question that if you wanted to solve it graphically, you'd either need to use Desmos online graphing calculator program or your graphing calculator. So what I'm going to do on my graphing calculator is I'm going to graph y equals 3 in one equation, and I'm going to graph the absolute value, which you can do with hitting the math button, going over to number, and hitting number 1. So math, over to number, absolute value, and we had 3x squared minus 3. So I graph it, I get exactly what I saw before. And on your graphing calculator, if you want to find out what these solutions are, we'd have to go second, calculate, where do they intersect? It'll always find the intersection point nearest the cursor. So if I push enter 3 times right now, it would find the one that we already know at 0. I want to find this one. I move my cursor closer to it, push enter once, push enter twice, push enter a third time, and it's 1.414. Ooh. So here, this point on the graph, 1.414, comma 3. Anybody recognize the number 1.414? Close to anything they know? Square root of 2. So we're going to find out algebraically if this is actually the square root of 2. And similarly, you could find this intersection point. You would find out, because of symmetry, negative 1.414, comma 3. So again, how would the algebra work on this one? If you were solving 3 equals absolute value of 3x squared minus 3, absolute value questions would tell you can split this up because the 3x squared minus 3 could just be equal to 3, right? And the 3x squared minus 3 could also be equal to a negative 3, then the absolute values would make it 3. This is the easy one. Move the 3 over. 3x squared equals 0. Divide by 3, x squared equals 0. Square root x is equal to 0. That was the one we could see easily from the graph. But on this side, move the 3 over and get 3x squared equals 6. Divide by 3, x squared equals 2. And when you square root, don't forget the plus and minus. Sure enough, it was the square root of 2. So we're going to see the algebraic way often a lot nicer than the graphing one. So let's go to part B. Part B, again. Oh, part B, I'm going to just write it out. I like part B here. You're going to like part B because if you notice this, 2x squared plus 4x minus, oh, okay. You're going to like this and then hate this as a graphing question because it said solve by graphing. What does an absolute value do to any number? Makes it positive. Will it ever equal negative 2? No, it's impossible. So the algebraic, this is how much work you'd have to, right, for algebraic. But it said graphically. So you still would have to draw both graphs. And I'm going to, again, do one in blue, so minus 2 in blue. I'm going to do, oh, this is painful. I'm going to do this in green, which means I have to do this first in orange. This is going to be so much work when we already know the answer is no solution. Because graphically, 1, 2, here's minus 2. Here's my blue graph. That was the easy one. Horizontal line, y equals minus 2. Now my orange graph. Do you notice that your orange graph is not in vertex form? So we would have to, it's good review though, right? How much do you remember completing the square? Right? So I'm going to change this to vertex form, which means I factor out the 2. I keep the minus 1. I factor out the 2 only out of the first two, x squared plus 2x. And then I leave a space. And the x squared plus 2x tells me it has to be x plus 1 squared. If it's x plus 1 squared, there would have been a plus 1 in here, which gets hit by this. So to compensate, I would have to subtract 2, giving me a vertex at minus 1, minus 3. Minus 1, minus 3. An a value of 2, so over 1 up 2, over 1 up 2, then over 1 up 6, over 1 up 6. And here's my orange graph. Then based on that, my green graph, this would stay the same, this would stay the same, this would get flipped up to 3. You'd have to do all that work and then say, where does the green graph and the blue graph intersect? They don't. So no solution. This would be really mean of me to give you this question as a graphing question, because you know the answer right away is no solution. But you would still have to do the completing the square to graph the orange graph, then to flip it up to draw it correctly, only to say there's no solution in the end. Could happen. Okay, 7 and 5B, circle those two.